Hello everyone, and welcome to the NEATEC Electronics series. This video is about encoders, so let's get started. Alright everybody, so what I've done here is I have tried to draw a chip, which is an encoder, right? Now for an encoder, and let's do this. Let's take this encoder and move it front and center, shall we? There's your encoder, okay? Now, an encoder has inputs. I'm just going to say inputs right here. Inputs on your left, how we're looking at it, and you're going to have an output over here on your right, okay? Okay. So, your inputs in this example, let's say we have 8 inputs. Let's call them D0, and here's D1, D2, down to D7, okay? See, I have 8 inputs here. Let's draw them. 1, 2, 3, 4, 5, 6, 7, 8. All right? Now your output, you're simply going to have 3 outputs. Okay, this would be Q0, Q1, and Q2. You got it? Now, let's look at this. If we output, suppose we output here. Suppose D1 is high and everyone else is low, right? Well, if we have an output which is 1, that's your decimal. That's going to be equal to 0, 0, 1 in binary, right? So this is your decimal, and then this is going to be your binary over here. So in that case, Q0 is going to be a 1, Q1 is going to be a 0, and Q2 is going to be a 0. Get it? Suppose instead of 1 being active, D1, I'm sorry, suppose, let's just say we have, there's a D5 here. I'm going to draw it right here. Suppose it's D5. Suppose D5 is active. What's 5? What's 5 equal to? That's going to equal 1, 0, 1 in binary, right? So in that case, the output will be 1, 0, 1. When you look at an encoder, it's basically the complement of a decoder, okay? That's basically what it's doing. So there are different types of encoders, and I want to get into that a little bit deeper here shortly. So I'm going to write a table, and I'm going to explain it to you about encoders. So see you shortly. Alright, so now I've drawn a table basically for an encoder. And you can see on the left side of the table, alright, this portion right here between D7 and D1, that's your inputs, okay? And your output is, well, right here. Get it? So if we were going to write equations for this encoder, oh, by the way, let's talk about this. You can see that for 0, everything, all your inputs are 0. You're going to have Q1, Q0, and Q2 be 0 on the output, right? And if D1 was 1 and everything else was 0, well, you would have an output where Q0 is 1, Q1 is 0, and Q2 is 0, and so on. You see, down to Q7, down to D7. When D7 is high and everything else is inactive, then you would have a 1, 1, 1. All right, right here. This should make pretty good sense to you, right? It's pretty straightforward binary. But let's write the equations for Q0, Q1, and Q2, shall we? So if we look at it, we're looking at Q2, for example. If you look at this column right here, when is it 1? Well, Q2 is going to be 1 for Q4, with D4, D5, D6, and D7. And I'm going to write these backwards for you. D7 or D6 or D5 or D4. Okay? Let's do Q1, alright? Well, Q1 is going to be active when D7 or D6. That's from these two down here, right? Boom, boom. And then we have to take care of these two, which is right here, which is going to be D2 and D3. So it's going to be plus or D3 or D2, right? Let's do Q0 now. The equation for Q0 is going to be, let me erase these prior notices here. It's going to be high for these 4 times, right? It's going to be high with D1, 3, 5, and 7. D7 or D5 or D3 or D1. Now, this is a non-priority encoder. Alright? That means that we'll only have one of these inputs active. In other words, it will only be a single one or a single active state. Everything else would be a 0. All right. Now, what would happen though in this case? Suppose you had D1 and let's say D4 active. Then you have a problem, don't you? Alright? Now, what a priority encoder takes into account is if this kind of thing happens, and there's a priority put in place, so it would take the input with the highest priority and output that. I'll see you shortly, and that's what we're going to discuss next. Alright, everybody, so I'm going back to the initial encoder, and I want to show you really what they do. So we're talking about, let's be clear on this, it's a priority, right? Encoder. Now, here's how it works. Suppose you have more than one input active, which I mean, when I'm saying active, I mean high. Inactive means they're low, okay? So if D0 is a 1, then this is all 0, 0, 0, all the way 0, except here at the very end, and D7 is a 1, okay? What we're saying, based on this encoder, is that the higher the number, the higher the priority. Got it? So in this case, D7 would have priority over D0 because it's higher, right? It's a larger number. So in that case, this would output 1, 1, 1. Get it? Now you could have multiple inputs active, for example. You could have D2 active as well. You could make D2, you could make D2 a 1, which But you know what? It doesn't matter. You can have as many inputs active as you want. Whatever has the highest priority is the one that's going to be output. And in this case, that's the one that has the highest value, or the highest number, which in this case is D7. Okay? So that's what a priority encoder does. Now, let's talk about writing the equation, right? The outputs for Q0, Q1, and Q2 for a priority encoder. To do that, I have to write a table, and I'll be right back. Alright, so I redrew a table here for you. And basically, on the left side here, right, we have Q0, Q1, and Q2. Those are your outputs. And here's your priority. And actually, I wrote 7 to 0. This stands for your inputs, right? This is actually D7, this is D6, D5, D4, D3, D2, D1, and D0. Okay? So let's think about this. How are we going to write the equations for each one of these? Because it's going to be different than a non-priority encoder, isn't it? So what we're going to do, we're going to write Q2 Q1 and Q0, right? Now let's go down through it. For D7, right, if each one of those are active, right, you want the D7 is coming in, you want them all to be on, right? So D7, D7. So if you have a D7 as an input, you want them on, right? Now, D6, it's going to be a little different, isn't it? You want Q2 and Q1 to be on, don't you? But obviously you don't want Q0 to be on with D6, do you? No, right? So, let's move on to the next one. Let's look at D5, shall we? Well, for Q2, we want D5 to be on, obviously, right? Q1, it's 0. We don't want it. Now, what about Q0? Here's the thing. This is what you have to do. You got to look up towards the highest priority, right? And if you see a 0 in the column, you have to include that. Think about it. You don't want it to be active if D6 is active, do you? Because D6 has a higher priority, right? So if you're looking at Q0, what you would have is you would have D6 bar. If D6 is low and D5 is high, then you would output D5. Get it? You have to look at both. If you don't, it wouldn't work, right? So let's look at D4. Well, obviously, D4 would be high on Q2, right? What about Q1? Well, Q1, it's still a 0, so that wouldn't be included, would it? And what about Q0? Wouldn't be included, right? So we'll leave what we have. Now we're going to go to D3, okay? For D3, there's nothing in Q2, right? Q2 Q2 has zeros for the rest of it, so basically Q2 is done, right? We don't have to do anything more to this equation, do we? It's going to basically revolve around Q0 and Q1, right? So now, let's look at Q1. Q1 is 1, right? For D3. But if you look above it, you have a 0 here and a 0 here. So, we're going to say if D5 is low and D4 is low and D3 is high, then make it high, okay? Or, and we have to take care of Q0 here, don't we? Q0 for D3, right here, talk about this right here, right? If you look up, you would have to have D6 low and D4 low, right? Because D6 has to be low, D4 has to be low, and what else? D3 has to be high. Got it? What about D2? Well, for D2, all we have to worry about is, where's my thing here? There it is. All we have to worry about is Q1. So it's going to be or, let's continue this. It's going to be D5 bar and D4 bar and D2, right? Then we have D1. D1, the only thing we have to worry about is Q0, right? This is going to get long. I hope I have enough room to put it all in there. Let's see. Let's keep going. So D1 is going to be D6 low. And in there, what, D4 low and D2 low and D1 high, right? And that's it. That's it. We did it. So there are the equations for your priority encoder. Let's go over this. It's going to be D6, D7, D5, D4. Then we have D7, D6, D5 bar, D4 bar, D3, or D5 bar, D4 bar, D2. That's right. And then we have D7, D6 bar, ended with D5. And then we have D6 bar, ended with D4 bar, ended with D3. And then D6 bar, ended with D4 bar, ended with D2 bar, and D1. So there you go. Those are the equations for your priority encoder. All right? One thing I didn't say on the last table that I drew, okay? When you have a table and it's showing a priority encoder, you have your inputs here, and you'll come down, usually separate, and then you're going to have some outputs over here, right? You have ones, if you notice, that came down like this, boom, 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 right? Up here was all zeros, wasn't it? I'm not going to draw them all for you, but I'm sure you can remember from the last drawing. Now, for a priority encoder, you can have what's called an I don't care state, or an X under here. In other words, you don't care if those are 1s or 0 because those have a lower priority when you set up your priority like this based on the value, okay? So when you see X's down below those line of 1s, that means you have a priority encoder, all right? Now, if someone decides to change the encoder priority right here, and if you're making your own encoder, you can, because this is simply, those are circuits, aren't they? These are OR gates, right? D7 ORed with D6, ORed with D5, ORed with D4, and these here are AND gates with some inverted inputs. You know how to build those. But if this priority was modified, for example, they put D4 higher than D6 and D5, whatever, you change the order, this may not look, this table here will not look the same, okay? So I want to just bring that to your attention. All right, everyone, we'll talk about multiplexers next. See you shortly. All right, everyone. So to end this video, I wanted to briefly go over a subject called multiplexers. Now, multiplexers, I'm going to draw the symbol generally used for a multiplexer, right? So it's going to come down like this, come in, come out, and then come back up. And you're going to have multiple inputs coming in, usually from the left, and you can have more than 2, but you can have multiple inputs coming from the top. And for example, we can call this S1 and this S0, okay? And you can make a truth table here if you have one S1, S0, and you could have this be 0, 0, 0, 1, 1, 0, 1, 1. So depending on what your control inputs, these S inputs are, okay, will determine what your output will be. And this is your output, okay? And this may be D0, D1, D2, and D3, okay? Now, I don't think I did a very good job drawing this. Let me just see if I can freshen this up just a little bit for you to make it look a little better, okay? So I use a different method of drawing here. You might like to see that. So basically, if you just come down here, this would be your long side, right? You could come in over here. This could just be your short side. And then you would have one come here and one come here, okay? And then this is your output, and you have your 4 inputs here, okay? Now, so for example, you could have 0, 0 output, and this would be your output here. You could output D0, right? If your S1 was high and S0 was low, it could output D1. This could be D2. This could be D3. So in other words, you have multiple inputs coming into your multiplexer and only one output, okay? You can think of it like a stereo system. You used to have stereo systems. You would have like a phonograph, you would have a tape player, you would have a tuner, you would have all these devices going into your stereo, and then you would have a selection knob. You would select which one you want to listen to, and then you would turn your knob to that location, and then your output to your speakers, that's what you would listen to, right? So what's going on the inside of your multiplexers? So I drew one of these for you. And what we have here, these are 3 input AND gates. Okay? Here, this is a 4 input OR gate. So, here are your inputs, D0 to D3, right? And here are your control inputs, right? S1 and S0. So if you simply look at them, it's quite straightforward. The AND gate, each one of the each one of these inputs goes to a separate AND gate. So the AND gate must have all highs for it to output a high, right? But really, what you want to do is enable these gates. And for a gate to be enabled, these other 2 inputs going to S0 and S1 must be high for the output of this gate to follow what D0 or D1 or D2 or what your data input's doing, right? So, for the first one here, if you want this to be active, if you can see that this input right here, okay, is connected to S1 bar, right? S1 bar, and this one is the one below it is connected to S0 bar. So if S0 and S1 are both low, D0 will be output, right? Right, it's going to be enabled for it. Now, none of these others will be enabled, okay? Now, if you look at the next one, it's the same logic. This one, for D1 to come out, you would have to have S1 bar, but this would be S0, no bar, because it's connected to the S0 line. If you had that, then your D1 would be output, right? Remember, it's going to an OR gate, so whichever is active is the one that would be output, right? D2, it's the same kind of thing. What do we have here? We have S1 and S0 bar. There's your bar. And finally, we have what? S1 and S0, don't we? There you go. S1 and S0. So basically, these inputs are going to control which of these gates here are enabled, and then that's going to determine which one of your inputs is going to be allowed to come through to the output. Okay? So basically that's all a multiplexer does. One thing I wanted to bring up before I ended this video is the concept of a demultiplexer. So it's basically a multiplexer in reverse. Basically with a demultiplexer you have one input and then you can send it to one of multiple outputs, right? So obviously a multiplexer, you have multiple inputs and you're going to choose which one goes to the output. The demultiplexer, you have one input and you choose which one of multiple outputs it's supposed to be going to. So multiplexers are switches, if you want to think of them like that. Okay? Alright. Well, I hope this final video has been helpful to you. See you soon.